Okay, if you're struggling on this problem, you're probably way overcomplicating it, because I've seen people use this rule and then mess up this problem. So let's review really fast. Let me get out of green. Let's go back to old school, just derivatives. If I gave you f of x equals x to the fourth, now let me get 3 times x to the fourth, how would you do this problem? Well, you would say, well, the derivative of that would be, it's the exponent rule. So if it's x to the n, the derivative of x to the n is equal to n times x raised to the n minus 1. You take the number, comes out to the front, and you subtract 1. Right? So this rule over here, the 4 would come out to the front, making it 3 times 4 makes 12 times x to the third, because it's 4 minus 1. This is no different. These problems are absolutely no different. So just because it's a decimal, who cares? It's still a variable to an exponent. So I'll do the first one here. The partial, all right, let it go away. All right, the partial derivative, well, actually, we'll start off with one. Partial derivative with respect to x. Okay, so take the derivative of this thing with respect to x. Well, so x has a variable of 0, or x is the variable and has an exponent of 0.3. So the exponent comes out to the front, making it negative 6 times 0.3, whatever that may be. That's negative 1.8, but whatever. So x now 0.3 minus 1. So that would make negative 0.7. Y is a constant, so it just stays the same. There's your derivative, your first derivative. Now, this notation you should recognize back from Calculus 1. It just means when you have that little 2 there, it just means do the second derivative. So we've already done one derivative, so we now are going to do the derivative again with respect to x. So here you already have your equation, and if you wanted to, you could simplify this to negative 1.8 x to the negative 0.7, y to the 0.7. Okay, so now this is our simplified version of it. So the derivative of this with respect to x. So again, it's just a variable x with a power of negative 0.7, so it's a power rule. So just this number comes out to the front. A negative times a negative makes a positive, so it's going to make 1.8 times 0.7 times x raised to the, alright, so the rule says subtract 1, so negative 1.7. Y is just a constant because our variable is x. So there you go. That should be the first one. And it's just rinse and repeat. So for the second one, do the same thing now, but with respect to y. Then this one here, what this is saying is, here we did 2 derivatives with respect to x. Here we do 2 derivatives with respect to y. Here what it's saying is we're going to do 2 derivatives, but do the first one with respect to x, then take the answer and do the derivative with respect to y. And here, very similarly, we're going to do 2 derivatives, do the first one with respect to y, then the second one with respect to x. So you're going to take the answer. First you do the derivative with respect to y, then take the answer that, do the derivative with respect to x. So I'll do one of those really fast for you, because you can see I've already done one derivative with respect to x. That lends itself to this problem really nicely. So now, to do the second derivative with respect to x, then with respect to y, well, we've already done it with respect to x, so what I'm going to do is take the answer to this problem, and now I'm going to do the derivative of this with respect to y. So I'm going to, instead of thinking of x as my variable like I did for the first derivative, now I'm going to think of y as my variable for the second derivative. So the exponent now would be the 0.7, so that's going to be negative 1.8 times 0.7 times x to the negative 0.7 times y, and subtract 1 from 0.7, so that'll make negative 0.3. And there you go. So there's your second derivative with respect to x, then with respect to y. Okay, hope that helps.